Hi everyone, in this video I'm going to give an introduction to Lab 9, which is about NumPy arrays, and it also uses object-oriented programming. This is due on Thursday at 11:59 p.m. I pushed back the lab times just to accommodate anybody that might be working or be taking other classes, but I still encourage you to start these as early as possible. In this lab, we are going to be simulating a game of Yahtzee. And so we're going to use NumPy arrays to generate lots and lots of random Yahtzee rolls. And we'll use that to determine how likely certain outcomes are. So in Yahtzee, there are 5 6-sided dice. And in our modified game, they're only rolled once. And we're interested in measuring how often 3 different outcomes happen. The first outcome is a high roll, and this is whenever all of the dice are either a 5 or a 6. Another outcome we're interested in is 3 of a kind. So here we need exactly 3 of the dice to be the same number, not 4 or 5. So for example, 4, 5, 4, 1, 4 is a 3 of a kind because there are exactly 3 4s, excuse me. But 4, 5, 4, 4 is not a 3 of a kind because there are 4 4s. And then finally, we want to measure how many large straights there are. And a large straight is when the 5 numbers can be arranged consecutively. So for example, 1, 3, 4, 2, 5 is a large straight because we could arrange these 1, 2, 3, 4, 5. You can see that there is a hint here that basically tells you to use the documentation and some functions that you might want to consider using, or excuse me, some methods of NumPy arrays. But we'll come back to that as we're going through the actual lab. So the first thing I want to do is just download the Python source code that you're provided. And I will open it with idle. So when I open this, I can see right away that we are importing NumPy, aliasing it to NP, just as we saw in the tutorial. And as we scroll through this, we can see that we have a die class already written for us, a Yahtzee class, and then a main. And we can see in this comment that it looks like we're going to need to add some methods to the Yahtzee class. But let's take a look at the code and get a better sense of what we need to add. So it looks like we initialize some variables to count how many high rolls there are, how many 3 of a kinds there are, how many large straights there are, all to 0. And then we create a Yahtzee object called game. And you'll notice that the constructor of the Yahtzee class takes in a number of sides. And for us, we'll just use 5-sided dice, but this is kind of cool. This Yahtzee class could be used to compute these likelihoods for any number of sides for dice. So we create that game, and then we repeat some number of times, which is whatever we pass into the main function. So as this code comes to you, it's 20,000. So as this is written right here, we would say for I in range 20,000. What do? We call the roll dice method of our Yahtzee class, so let's go take a look at that. What does roll dice do? It then, for each element of this rolls array, we can see that the constructor creates self.rolls as an array of zeros that has length 5, and you can see we also set the type to be int16, so that's a very succinct, small way of storing integers. So for each element in that rolls array, we set it to whatever rolling a die does. And if we were curious, what does the roll method on a die object do? Well, we can just go ahead and look at the definition of our die class. So when we call the roll method, we just return an integer between 1 and the number of sides. And so for us, we know the number of sides is 6. So when we create a die object and then call roll on it, we are getting back a random number between 1 and the number of sides. So roll dice is how we set the values of all the rolls of our 5 dice. Then there are 3 if statements here that check, is this roll a high roll? Is this roll a 3 of a kind? Is this roll a large straight? And if any of these are true, then we increment our counts appropriately. And so if we run this, let's just see what happens. We see that we get an error because our Yahtzee class has no method, is it high roll? And that's what gets called. For example, right here, we call on game is our Yahtzee object, and we're trying to call the is it high roll method, but it doesn't exist. So what are we going to need to do? We're going to need to define is it high roll, and since we are calling this using the dot notation on a Yahtzee object, we know that is it high roll is a method of the Yahtzee class, and that's why it needs to be indented to the same level as all the other methods, and it also needs to take in self. So we see that is it high roll doesn't take in any parameters, but when we define the method, we have to put in the self variable. Now what should this do? I'll just put in a docstring comment to say what it should do. Is that 3? This is just another way of writing comments, and this should return whether this roll is a high roll or not. And for now, I'm just going to pass. I also need to define is it 3 of a kind, so I'll just do the same thing here. Is it 3 of a kind? That also takes in no parameters. Return whether this roll is a 3 of a kind or not. I'm also just going to pass here. Oh, excuse me. This is it large straight? Is it large straight? This should take in self, and this should return whether this roll is a large straight or not. And actually, instead of passing, I'm going to return false here, because I know that these should return a Boolean, because we're using them to check whether this roll was the specific outcome or not. And that's why we're using them in if statements. So that's why we want this to be a Boolean. So now let me see if this runs. And it looks like it does run. So we're getting some output. The number of roles that we're testing is 20,000, and we're getting 0 high rolls, 0 three of a kinds, and 0 straights, but that's because we're always returning false. Now if I do something like change how many rolls we're doing, let me run that, we'll see that reflected, we're only doing 200 rolls. And while you're developing your program, I would actually suggest doing a small number of rolls and printing out your results as you go. So let's say I wanted to see, what is this self.roles variable? Well, when you turn in your code, you shouldn't change anything below the line or above the line, but as you're developing your code, I would say that it's a really good idea to print things out. So for example, let's say we add to roll dice, print self.rolls. So once we get the values of these rolls, let's just take a look at what they are. I'm going to run this, and now I see, so there were 2 rolls. The first one was 16266, and the second one was 66563. And so it's this self.roles attribute that we're going to be looking at to determine whether the roll was a high roll, whether it was 3 of a kind, whether it was a large straight. So the basic idea, use self.roles. What is that? It's a NumPy array. To figure out whether this roll is a high roll or not. And so you're going to have to figure that out. As a demo, let's actually work through a method that you don't need to implement, but that maybe we could want to implement. So let's just make a really simple one. I'm going to say contains a 1. Let's say for some reason we want to compute return whether this roll contains a 1 or not. So to start off, I'm just going to return false here, and I'm going to add some code down here so that this will behave how I want it to. So I'm going to say game.contains 1. It doesn't have to do anything. And I want to count these. So I'm going to say contains 1s equals 0. And I'm going to increment contains 1s every time I have a roll that does contain a 1. And then I want to print these out. So I'm going to need to do that. So bear with me while I update my code. So number of contains 1s. And this should print out contains 1s. And then what will the percent be? It'll be contains 1s times 100 divided by the number of rolls. So now let's just see if this runs. And we are not adding a new line. I will do that just because I want it to be consistent. Okay, so now let's work on this contains 1s function. So I want it to return true, for example, on this input, because there indeed is a 1 in there. There's 2 1s. And so one thing I could imagine doing if I kind of want to just brute force this, I could look at each position. There's only 5, so it's not too big a deal, right? I could say if self.roles, because that's my NumPy array that contains these role values, and I know that with NumPy arrays I can use indexing just like with regular Python lists. So if self.roles at 0 is 1, then I should return true. Otherwise, if self.roles at 1 is 1, oops, I should return true. And I could keep doing this, and if I get to the end and I haven't seen a 1, then I should return false. So this would be a totally legitimate way to solve this problem. However, I want to demonstrate a slicker way of doing this. So that was one option. Let's solve this by, first we're going to create an array of counts for each integer. So for example, well, I'll show an example in a second. And then if the counts of 1 is 1 or more, return true. Otherwise, return false. So let me show you what I mean by an array of counts for each integer. So the only reason that I am suggesting this as a possible solution is that NumPy actually has a really nice function for doing exactly this. And I will show it to you via the documentation. So here we're returning to this hints section. So it says NumPy arrays have a lot of methods, and the NumPy library contains a lot of functions that can take in arrays and do computations on them. You might want to look up the max, min, and sort methods and the bin counts function. And you might also have other ideas while searching in the documentation. So I'm going to open this up, and we can see that we can search here. So I'm going to search bin counts because that's the function that will generate this really useful array for us. So this function is numpy.binCount, and what it does is it counts the occurrences of each value in an array of non-negative integers. Well, what do we have in these roll? What is roll here? Well, it's an array of non-negative integers, so we can call the binCounts function on it and get back an array of the counts of the values. So I'm going to say make a variable counts, which will be assigned to be the array that comes back from np.binCounts of self.roles. So for example, this is passing in 36343, and I'm going to print counts, and I'm also going to add my return false back in there because I deleted it. So now we can see we're still going to print out the self.roles variable, and now we're going to print out this counts variable. Let's take a look. Ooh. I believe that the mistake that I've made is that I called it bin counts, but it's actually just bin count. So let's change that. Yes. Now let's run this. All right, so our first role in this randomly generated instance was 4552. And what is this counts array? Well, in the first position, it gives the counts of zeros. Second position, it gives the counts of ones. Third position, counts of twos. Fourth position, counts of threes. fifth position, counts of 4s, and sixth position, counts of 5s. And let's just double check that that's really correct. Well, there are 3 5s, and that's why there's a 3 in this position. There's 1 2, and that's why there's a 1 in this position. And there's 1 4, and that's why there's a 1 in that position. So bin count has, in fact, given us an array of the counts of each value. So now, what do I need to do? Well, I just need to return whether or not counts at 1 is greater or equal to 1, right? Oh, and then that's all. So in this case, right here, what would we return? Well, the count of 1s is 0, so we would return false. Let's see, in the second one, we would also return false, because there's a 0 here. But let's try it on a new input. And we'll see if we got the correct output. So for this one, there is a 1, and it looks like we did register that the number of contains 1s is 1. Let's actually continue printing counts just to double check, and maybe I'll do 20 so we can make sure that we see a lot of outputs. So, for example, this one, there's nothing in that first position. This one, there is something in that first position. And just to give us even more information, I'm going to print counts at 1 greater or equal to 1. And we'll just double check that, oops, this is where I want that space. Just double check that we're getting the right thing. So let's just check one of these. So this one returned true, and that looks like it's right. There was a 1 in there, and we had a 1 in the first position of that counts array. So that was just an example of looking up some functionality of NumPy arrays and using it. And so when in the end, you should run your program on all 20,000 or at least some large number. Let me remove any printing so we don't print 20,000 copies. I think there's no more printing. So let's go ahead and run this. And so we can see that overall it looks like about 60% of the time our roles contain at least 1 1. And as you're developing this, the way that you'll know that you have a correct solution is you can take a look at the output, and you can see that you should get about certainly less than 1% of the inputs should be high rolls, about, let's say 19% should be 3 of a kind, and about 3% should be large straights. Since these are random inputs, you might not get the exact same numbers, but as long as you're close, then you'd know that your program is behaving correctly. So that is the NumPy assignment. Good luck with this one, and please ask questions if you have them.